It is a longing that always begs a question. And it is always demanding from us an answer. This world is our response to that question. I embark on this long journey with one query in mind. Where did we come from? And how did we get here? We are constantly propelling ourselves toward the future, but we never stop wondering about our origins. You and I have now arrived at the very entrance to the past. Up ahead we find the heavenward path of those who long to know the world's secrets. Without hesitation, I shall climb the stairs they provided. This longing will take us to the faraway time of the ancients. We shall now encounter a spirited people in a dynamic age who eagerly wanted to learn all the secrets the earth was hiding. What they longed for was not something to be seen. Indeed, it was something that must be found. Are you ready to join me on this amazing journey? The longing has for ages been a secret that slept with the legendary pharaohs of Egypt. The human heart is easily taken in by things shiny and valuable. For over 4 millennia, the longing has been waiting patiently for this moment. Now, it is about to open the floodgates on the secret knowledge of the world. This place is a pilgrimage for those who wish to seek out our origins. It is a land filled with contradictions. Desert juxtaposed with farmland. Barrenness and abundance. the dead, and the living. Myth and history. These extreme opposites coexist in this land as naturally as the sun and moon. Right now, I am headed to the place where it all began. Luxor, Egypt was once teeming with grave robbers. In the days of ancient Greece, it was called Thebes. Even today, it still keeps its old secrets. Our story begins with a papyrus scroll found here in the Ramesseum at Thebes, a memorial temple dedicated to Pharaoh Ramses II. Ahmes the scribe organized a series of topics that are to be learned by apprentice scribes. These are subjects that have been passed down for 2,000 years. They are important for resolving issues faced within the kingdom. They are math questions. In the time of Ahmes, only high-ranking officials knew math. Ahmes pauses when he encounters difficult questions. He is an intellectual, diligently laying out plans for the future of the kingdom. The dry desert wind blows throughout the day. The birth of civilization was a difficult ordeal. In ancient Egypt, power centered on a single person, the pharaoh. A great deal of resources was required to maintain his image, one centered on a pantheon of gods. The pharaoh was constantly building temples for Egyptian divinities. The pharaoh prayed for the safety and livelihood of his people. In return, they gave the pharaoh reverence, obedience, and endless labor. This unspoken contract meant an endless cycle of construction and destruction of temples, lasting nearly 2 millennia. This temple is the size of 30 soccer fields put together. It is a large-scale colonnade temple with 134 large columns. We're at the first of a total of 10 gateways. This is a temple dedicated to the deity Amun, the king of the gods in Egyptian mythology. The colonnades here are 23 meters high and 15 meters in circumference. The distance around one of them is as long as 9 adults with their arms spread outward. This was a splendid temple, glorious in its color. Amun, who represented the essential and the hidden, was the patron deity of the pharaoh and of the Egyptian kingdom. Amun-Ra was a combination of Amun and Ra, the ancient Egyptian sun god. The deity we are about to meet also resides in this temple. It is said that there were as many gods in ancient Egypt as there were people. And among them, there was a deity who helped people do math. This is Hapi, the god of the Nile. He was a harsh deity who sent annual floods along the Nile in a country that experienced little rain throughout the year. Egypt has very little rainfall throughout the year. Yet the Nile flows freely like this. How can this be? In order to find the reason, we must sail far upstream. This is the world's longest river, 6,600 kilometers long. The fact is, there is often abundant rain in countries south of Egypt. The rainy season in Ethiopia and Uganda is the source of water for the Nile River. Ancient Egyptians who were unaware of this believed Hapi brought water to the Nile. The river's waters left sedimentary deposits from the upper river to the delta. The rich black soil that resulted was revealed whenever the water subsided. Every year, the fertile soil was replenished, but the land boundaries were completely obliterated. Returning use of the land to this people was an important responsibility of the pharaoh. Re-establishing plot boundaries was a math problem. Some of the borders were curved, not straight. And this required a way to find the area of circles. Calculating the area of a circle required pi, a value of about 3.14, but pi had not yet been discovered. How could they determine area? This was problem number 50 on Ahmed's list. Find the area of a circle that is 9 ket in diameter. But first, we must determine what a ket is. This is a finger, perhaps the smallest natural unit of measure to the ancients. The Egyptians measured length using the human body. The next largest unit was the width of 4 fingers. In the human body, 6 times the width of 4 fingers was equal to the length from the tip of the fingers to the middle of the arm. The length of the forearm was 1 cubit. and there are 100 cubits in 1 ket. A length of 9 ket would require a lot of people standing in line. 100 cubits makes 1 ket. The problem written on the papyrus referred to 9 ket. That would mean 900 forearms needed to determine 9 ket. 900 people with their forearms out are lined up side by side. So this is a circle with a diameter of 9 ket. How could the Egyptians determine its area? First, they divided the diameter by 9. Then, they eliminated one of the 9 sections. This left them with 8. The area of a square with a side that is 8 units long is 64 square units. This would be the area of the circle as the Egyptians calculated it. So how did they know that the area of such a square would equal that of a circle they're calculating? This is a square made up of 64 pebbles. Try reworking them into the shape of a circle. The number of pebbles in the diameter of such a circle is 9. This is how they concluded that the area of such a circle and square are about the same. Let's calculate the area of the circle using the value of pi. It turns out to be 63.59. The Egyptians calculated it at 64. That's a very negligible difference from modern mathematical methods. We are curious why they needed such accurate calculations. We visited the tomb of an aristocrat who lived back in those times. The person interred in this tomb was a high-ranking government official who imposed taxes on wheat production. His duties are depicted in paintings on the wall of the tomb. Agriculture was the primary source of income for the kingdom's treasury. In order to levy taxes fairly and accurately, scribes documented everything. Tax evaders were caned. Each year after the annual flooding, government officials went out to survey the land. For accurate taxation, precise land measurement was crucial. Farming began long before the harvest. To properly distribute land to the farmers, the officials had to study diagrams. In other words, they relied on geometry. They made knots in rope in order to measure length. From there, plots were determined. The measurement of area required another form of math, multiplication. Measurement of land area was so important that it was mentioned in 13 problems on the papyrus. A triangular or rectangular plot of land required multiplication. So how did Ames calculate them? For example, how was an area of land, say 4 meters by 5 meters, measured? 4 by 5. 4 times 5 is 20. The thing is, the ancient Egyptians didn't have our present-day form of multiplication. So how did they figure out the area? 4 by 5. Let's start by placing 4 white pebbles on the left. Then place 1 black pebble. Then we double the pebbles on each side. Double of the right side is 2. We repeat this until there are 5 black pebbles. Now we've placed 5 pebbles on the right side. At this moment, the number of white pebbles on the left is 20. Now the measuring is done. The farmers can get on with their work. Addition and subtraction are still as important to us as they were to the ancient Egyptians. By finding solutions to these problems, we've been able to achieve all we have right now. Now we know the secret of the river. Still, the geometry displayed around the river is always magnificent. This market is a gateway to a different world. Along these streets, we can find a variety of mathematical examples. The exchange of goods for money is itself a perfect usage of math. In fact, we humans do math by instinct, even if we don't always recognize it as such. Simply by looking at things, we count them, and we determine their quantity. Sometimes we measure height. For some objects, area is very important. Our brains are always kept busy in the marketplace thanks to our sense of math. So how on earth were we able to obtain the ability to measure, weigh, and count? Long ago, when we humans were still nomads. We counted sheep since we couldn't figure out how many there were just by looking. Humans learned to herd sheep instead of hunting. They kept their eyes on the sheep from a distance in order to protect them from predators. Measuring distance was indispensable to survival. Determining visible distance is part of the mathematical instinct, and it's one of the origins of math itself. Counting numbers occurred long afterward. Many animals are superior to humans at determining distance, but humans eventually advanced from beyond that point. The landscape these shepherds see every day would be the same. sheep, trees, rocks, and perhaps another shepherd. Humans began to categorize these things. But for things that had little or no relationship, how were they grouped? Perhaps they could be separated into what's in the sky and what's on land. Things could also be separated into those that are alive and those that aren't. How about edible and inedible? Well, then how about this? One, two, three. Only humans do this. Three sheep equals 3 rocks. This is how humans discovered the numerical concept of objects. Humans began to keep track of the value of the sheep by putting pebbles in a container. These are some of the vessels used to hold the numbering pebbles. Since these devices represented property, we can think of them like a present-day bank book. The holes of the surface indicate the number of pebbles inside. Until recently, archaeologists were unaware that these marks represented the number of items inside. Such numerical concepts are hard to catch. Now, we no longer need such containers and pebbles. What's left is the concept of objects. We know how many sheep there were simply by these marks. It took tens of thousands of years for humans to figure out these simple mathematical concepts. Much like an infant taking its first clumsy steps, the beginning of math was slow and awkward. Eventually, these were developed. The ancient Egyptians created beautiful hieroglyphs, including numerical symbols, by imitating the objects around them. This is easy. The number 1. It's a wooden stick. This represents 10. It's shaped like a hoof print. 100 was represented by the rope used for measuring land. The basic knot was 100. 1000 was represented by the lotus, a flower commonly found throughout the Nile region. How then would a large number like 1 million be depicted? Such a great number was represented by a person with his arms raised outward in surprise. And what do all these numbers add up to? It's 2012. We learned these numbers when we were young, and since the time that numbers were introduced, the growth of civilization began to accelerate. I am now approaching one of the most majestic constructions in human history. Until the 19th century, no human being was able to build higher than this pyramid. Does that mean that ancient math was more elevated than our own? Perhaps it was. The pathway into its depths is unexpectedly narrow and steep. I had to crouch as I made my way 60 meters downward. The ceiling inside, however, is 12 meters high. How did the ancients raise up such enormous stones? We know that the ancient Egyptians made layers with overlapping stones, which meant they had to calculate the stone's weight from the beginning. Their meticulous calculation is why this hasn't collapsed in 4.5 millennia. The surface of the stones is smooth, but the air inside seems heavy. Building this structure must have taken an incalculable amount of labor. About 10,000 workers were exploited for this task. The tremendous cost of feeding and clothing the workers had a profound effect on the livelihood of the kingdom. The pyramids presented some very difficult, unsolved math questions, but more important math problems were found in other locations. Recently, near the Great Pyramid of Giza, an ancient village was found nearly intact. After much study, it was determined to be the home to those constructing the pyramid. During the excavation, skeletons were found, not only of men, but also women and children. This indicates that the pyramid workers may not have been captive slaves, but perhaps contracted employees. A large-scale construction site typically has a workers' village like this nearby. A family tended to have 6 or 7 children on average. The alleyways must have been full of children. The workers labored for 8 days in a row and then took off 2 days in a row. If they became sick or had other problems, they were able to take 6 days off. Women cooked for the whole family. A husband, a wife, and children. The life of those who lived 3,000 years ago wasn't so different from our own. This was a typical day in the workers' village. The kingdom paid the workers a monthly salary. Currency had not yet been developed, so they were paid in bread. This was payday for 10 workers. But what if the officials brought 9 pieces of bread to pay them? Each one can't get a whole piece. Would only 8 workers get their pay? That would be unacceptable. Such unfairness might lead to conflict. So they had to develop new numbers. This is how the fraction appeared. 2 fingers under a mouth meant half. 3 fingers meant 1/3. 4 fingers a fourth. And 5 fingers a fifth. The Egyptians used fractions whose numerators were 1. We are not certain why, but 2/3 was an exception. They had to divide numbers using these fractions. Now we can distribute 9 pieces of bread to 10 workers equally. First, we use the biggest fraction, 2/3. All 10 workers each get 2/3 of an entire piece of bread. Then, we find a fraction that can be used to divide what's left into 10. A half cannot be used to divide the remaining bread. A third? A fourth? Bingo! A fifth works. The remaining 1/3 is divided into 10 portions using 1/30th. Each worker ends up with 2/3, 1/5, and 1/30th of a piece of bread. Modern math today would represent this as 9/10. 9 pieces of bread to satisfy 10 workers. It was a remarkably fair and balanced result. This was possible only through math, an invisible but potent force. We live in a world without knowing the full power of numbers. We see geometric diagrams dance. Time is always ticking, ever forward. The modern city is full of brightness. This city was born from a desert filled with harsh wind. After recording the 84 math problems, Ames the scribe wrote a prologue. He wrote his name in the year he transcribed the questions. And in the end, he added a secret that only a few people knew about. The entrance to all objects and the key to all secret knowledge is math. We've waited a year to take a look at this. In this city, there's one thing I have wanted to see. After a long and nerve-wracking wait, we were finally approved. The security check to see this is very intense.
A lot of the collection in the museum is not on public display, and this is where we keep the reserve collection, including the Rhiine papyrus. This corridor is the Rhiine papyrus, simply because it's the only space we have where we have a wall long enough, and we keep it covered with cloth to protect it from light at all times, except when people want to see it. It's a wonderful, wonderful papyrus.
This is the original papyrus scroll upon which Ames wrote. It was handed down from robbers to merchants. It finally arrived at the British Museum. This humble scroll has led us to the origins of everything in civilization. Here, we see problems we have solved so far. This is the one where 9 pieces of bread are divided among 10 workers. This is where they calculated the area of a circle with a diameter of 9 ket. We know there are even more amazing stories in this scroll waiting to be told. The first leg of my journey has come to an end here. Now, I take a step toward the next civilization.